Hi. Welcome again to the Introduction to Software Engineering class. And so in this class, we are going to cover introductory concepts for now, and then we are going to move to more advanced concepts. And we will start by understanding what are we doing. We are going to answer to the question, what is software engineering? Okay, so what is software engineering? This is going to be the first question we are going to answer to in this video. And in the next video, we are going to see like other two important points, which are the iterative development lifecycle and the software development activities. Okay, so to define software engineering, and we are going to like break this word into software and engineering. We'll talk a lot also on software. We were already discussing things related to software in the previous like introductory video. And now let's focus with the word engineering, because this is a key. And so engineering is kind of a job. If you are taking my class, you are learning software engineering, there is a probability that you are going to be applying for jobs or you want to become a software engineer. So when it comes to engineering, it like includes a full range of activities. So it's not only about software engineering. Software engineering is one of them, but mainly the concept of engineering is that ability that is going to be developed in you through this course to identify a need for a new object, and you are going to go through different phases while inventing, I would say, this object to the end of its use. You are going to come from the idea, from the abstraction, which is going probably to be your project in this case, and then you are going to have like an illustration of that. So this might involve the representation formalism, the use of technical resources, the mastery of technology, research outcomes, pragmatism based on experience, products that meet comparative standards, and so on. Okay, so this is engineering. It's mainly about thinking, okay, and coming up with a new object, I would say. So now I'm using the word object, but in the case of like construction engineering, this object might be a building. And as you can see around, we are surrounded by buildings, and there is a lot of like design art, I would say, by humans. So this design activity is a general concept, but in different fields, there is different, I would say, specific activities related to this in the real world. Now, starting from the building example, okay, which as I was mentioning, it's a product and which is actually developed. And the same way that we're going to develop a software, someone has developed a building, okay? And we are going so to see this development. What is behind this development is a set of, I would say, decisions that were made in order to build this or to have this end product and this very nice building, which is like it's an hotel in Singapore. Okay, so this building includes a set of activities which are needed to achieve this, right? It's really nice. I like this. So many decisions have been taken and around the planning of this project, and many people has been involved in this project. There is teamwork, there is a synchronization, there is specific plan, and there is a set of questions, probably how many buildings are in this room, or how many rooms, excuse me, are in this building, or how big is building this building is, or how big is each room within this building. And so all this is about the design of the building. You can see the design is actually nice here in this picture, and it's actually like where a lot of decisions are taken, and decisions maybe about materials as well. Which materials are we going to be using, and the different steps, like from planning the project, the simulation, the testing, the maintenance, and so on. Okay, so this is for the particular or specific case of this hotel that is, as I was just mentioning, having a given purpose, going through different phases or life cycle, I would say, and there is a like real plan for all this, and many questions that need to be correctly answered, and many people that needs to be involved in order to have this achievement, I would say. So this is the case of constructing engineering. And engineering is not only about constructing engineering, it's not only about software engineering, but all engineering tasks, they require the same activity. There is the same, like different steps, I would say 5 steps, that we follow no matter what, usually. So the first one is the requirements elicitation. In this context, it's kind of a specification, and we need to answer 3 questions. They are famous, like, and you will see them later all the time. The what are we going to make, what it is going, like it will do, sorry, and how it will do it. What it will do, how it will do, and what are we going to do at the end. So these are the requirements, these are the specification, and these we usually start with, okay? So that, or we have talked, this is in the beginning when we want to come with that object, that product. We need to have a specific customer, I would say, a specific potential user, I would say. And these are people who probably will be the users of this product. So these, we need to understand them, and we need to really understand the expectations from us as engineers that are going to help them with designing the or giving at the end the final product. After that, we need to move to the design phase, and what will it look like, and how will we make it in this case, and at least like having a mockup, having a set of interfaces when it comes, like someone needs a mobile app, and I need to imagine, okay, this app for that user, or let's say this user is a student, and this student wants something like Blackboard, I would say. So what is, how it will be looking like, the arrangements, where I will put this, which component, and so on. So this is kind of a first draft, I would say, or the first look, I would say, of this system. And then what we have, we're going to build it. It's not only we're going to keep it like the design on paper, or no matter the tool, we need to start building things to design on the set like of the requirements specification. So the next now we need to move for testing that. Once it's done, all these specifications are built, we need to test that, and we need to imagine or think about different scenarios and to test our final product. And then once it's there, it's released. So we need to keep maintaining it. We need to keep trying to maintain the quality or to enhance the quality, let's say, by different, I would say, refactorings, ameliorations, modifications, and so on. So again, the goal in this course is to go through all these activities during the whole semester. So this is what we are going to be doing. And I would love to start a motivating, it's not history, okay, it's from history, but this is a reality. Why we are talking and why I am today teaching software engineering, why you are today taking this class, it's showing the importance of this like topic. People are graduated, becoming engineers, software engineers. We are working on software development and so on. But why is very important? We need to understand things from the very basic, I would say, foundations, or we understand the story from the beginning. It starts in 1970, And there is something well known that you need to know if you are a software engineer. This is known as a software crisis. So it's like kind of people are not willing to invest in software anymore. And those like people with funds do not want to give their money for software anymore. What is the reason? The reason is that software it's becoming very like there is a lot of production of software and the cost of maintenance it's becoming very high and it's higher than that of the hardware development, which means I'm giving you software, but go spend on that software, go keep maintaining that software, and it needs lots of corrections, lots of work on, and so on. So there was a significant decline in software quality. Once there is the decline in quality, people they don't like to bring this headache and invest in like designing software, I would say. At that time, probably I'm not supposed to use the word design. People are not willing to work on software. You will understand what I mean. So the idea is that this crisis, it's mainly due to some problems. Developers who were just jumping into coding. Developers, like, they just think, oh, we need this. Okay, tuck, 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 tuck. I'm coding it. Take your product. So this is resulting in what? This is resulting that they were like going with random steps. They do not have any like steps to follow or any like any, I would say, process. So what was happening at that time if everyone is doing producing, I would say, software? So most of the softwares, they are inadequate. I'm going to illustrate this concept. And inadequacy is the idea is that requirements were not met. Means if I am the client and I want something, you are the developer and you are creating this, I would say, software for that thing. What I'm asking is something, what you are giving me is something complete, something else. So all the time there must be too many changes in order to meet the requirements. Another reason is that there is a problem of schedule overruns, which means that software were often delivered late. So if I need a software today itself, and you are saying to me, okay, I'm gonna do that. So you will be taking 3-4 years and software is not there. What is the use? I don't need it at that time. I need it right now. I need it next month. There is always some time frame that must be respected, and that has never been respected, unfortunately. There is another problem, which is the cost of runs, which is budgets were exceeded because we keep maintaining that software, so we keep spending on that software, and so it's like costing a lot of money. So also the problem, like I'm mentioning, in unreadability, which is software frequently failed or crashed. So this is related to quality. Also, there is a problem of maintenance difficulty. So software was complex and costly to maintain with too many communications, links, and interdependencies between modules. So all this is a problem, but I would like to highlight the first one, which is inadequacy, which is a very important point. So in USA, in 1979, this is a real report mentioning that 70, given, sure, this is a survey, given a number of projects, 47, excuse me, 47 projects, which is almost half of these projects, which are delivered, they have never been useless. So 29% of these projects, they are paid for, but never delivered. There is also a 19% of these softwares that are used, then modified, or just completely we are abandoning them. We are not using anymore. And so after that, what we need to do is we have 3% of software that used after some adjustments, and only 2% use it as it is. So imagine you are investing in software, only 2% are used without any problems. 2%. It's really less. So this is really crazy. And this is why? This is due to inadequacy. So I would illustrate with this amazing, like, I would say, figure. And you will find me sharing memes like this and figures, illustrative pedagogical figures like this in Discord. So this is how the customer explained it. You say, I need this. So this is what is in the brain of the customer. Okay. And the customer is going to some project leader and explain it for him what he needs. He explains that in plain language, we say. He explains that in English, for example, in French, Arabic, or no matter what is the language. And if we are having someone explaining to someone else, I can explain something, you can understand something else. It happens, we are humans. So the project leader can understand something like this. It happens. Then he's going to discuss with his team, and this is what the engineer is designing, okay? And the programmer who is going to write that code is doing something like this. And the sales exclusive is describing product like that. So you can see at the end, the billing or the customer is charged like this. And at the end, the customer, this is what he explained. But in his mind, this is exactly, or this is what he needs, as simple as this. But you see, because there are different, I would say, stakeholders, and we will make this word later, stakeholders or decision makers or different people who are involved in this project. So this, like, inadequacy can happen, or I would say misunderstandings. So this can create a lot of problems and cause a lot of loss. So now this is clear. And so this is from where this mess is happening, and the software crisis is there in 1970s. So to address this crisis, what people try to do, they try to apply some kind of traditional engineering methods that we will see so far. And the goal is that the people, they started thinking, they said, we need to have some solution for this. And they were providing some rigorous framework to guide the software development from design to delivery, control costs, assess risks, meet deadlines, and try to overcome all the problems that we were just discussing, related even to quality, the quality of the software, by establishing several criteria. Okay, so and this made birth to the software engineering. So this is the story, and this is the morality, and this is the need, and why it's happening, and so on. We are going to start by introducing now or moving to another real case, which is related to you guys. So what you are doing, mainly, you mainly are trying to understand things. You maybe took some programming classes before, and now what I can like tell you is that this is not a programming class, but it's mainly about the understanding of how to build the product in general, not just by doing that, or no, it's not a coding thing, just we are going to understand the whole pipeline, I would say. And again, I want to emphasize that this is not a programming class. I will keep saying this. Okay, so this is the main focus at this class, and I think that you are already taking different coding or programming classes in different programming language. Still, I need, if you are talking about developing your software, even like at the beginning, it's not about programming. It's not like you're going to jump programming and then there will be a huge problem. Now, if you are programming things, so that would probably start, as you know, so if there is some implementation, mainly or probably one can work, one code can work, another code cannot work. Some codes need some tries, not first try, look, it's not working in the second try, maybe fifth, sixth try, and maybe more even probably. So at the beginning, things are not perfect, and you need to change or keep changing or giving that little bit change to your code. And after that, probably after fixing your code 5, 6 times, you find that it's working. So you have your code running. Well, finally, it's not an easy thing to have the final like output, but it needs several tries, and this is what you are learning in some small programming, I would say, problems. But in general, what we need to learn is that we need to learn the stuff beyond programming. We need to learn how tests like may program, how to generate the right test cases, and how to identify errors in my program, how to probably validate the requirements of my customers to make what they expect from me and to make the accurate implementation. So it's exactly what my customers are asking me for. This is what you are going to learn, and this is what we are going to discuss in this class. Okay, so we're going to learn about testing, rereading, rethinking, tracing, and debugging. And after all these like steps, I would say the magic happens, and you may decide that, okay, my software now is fine, and I won't like make any changes anymore, and that's enough. However, these several steps like are not usually in this order. It's not like you're going to test first and then you're going to debug and then you're going to rethink, or no, you are not having any pattern, I would say. Okay, so this is how it works, and mainly this is beyond, I would say, programming. So we have some steps to follow, and the steps, they look to be simple, but they make a big change. The first step is to understand your problem. You need to understand what are you doing exactly. So it's not like you just jump programming. I would say this is the last step. So you need to understand the problem and what we know the requirements. And for requirements, there are two types of requirements. Some of them are known as functionalities, which are the main functionalities of a system. Like I want a platform or a software for e-learning, like Blackboard. The main functionality that students and professors must have some common space to share, exchange, and so on. So this is one of the main functionalities. If it's not there, it's not what I am expecting, or I am misunderstanding the problem. However, there are some other non-like requirements which are non-functional. Non-functional means even if these requirements are not there, my code, my app, I would say, or my software is working and it's okay. But if they are there, it's nice to have them. Probably they're taking things towards perfection. Like, for example, if we have Blackboard and it's secure, that's nice. If it has a nice interface, it's easy to use, is marketable, has a good performance. All these things are not the main requirements, but if we are having them, it's good. So these are known as the non-functionalities. Okay? And this is the first step of understanding or trying to think about the problem, what are the potential requirements, and whether they are functional or non-functional. Next, we have, or we need to perform some design, which is a very important step. We need to have, based on these requirements, we need to try to go through the requirements, and we try to look at the property, how to decompose all of these requirements into different design cells. Like, for example, I was mentioning into diagrams, like class diagram, for example, sequence diagram, activity diagram, and so on. And this is, I would say, the way that we are going to think, and we are going to think about the constraints at the same time. We can consider that, such as speed, user interface, the looks, programming language, and dependencies. Okay, all these are non-functionalities. We are going only to consider mainly the input, output, the data, the formats, and so on. Okay, so this is the second step. First step, you need to understand the problem, the requirements. Second step, you need to perform some design based on this requirement. Keep in mind, you're not going to perform design given something else. You need to stick to your requirements. The third step is now we start implementing or coding. So the implementation is a part of this life cycle, I would say, but we have to go through this while making sure that we are using the right programming language. We are based on the right design, and we are programming the exact needed thing. Next, we have the fourth, or I would say the last step, which is about now we have understanding. We are already understanding our problem. We are having, I would say, design. We are designing this problem. Then we are coding that. Now we need to validate or test the program, which means that we are going to check the output of this program is expected or it's behaving in an unexpected way. So this is what is known as generating test cases and making sure that everything is okay. So we keep watching the behavior of this program. If it's working as expected, as designed, or there are some unexpected results, I would say. So if everything is okay and all test cases produce the expected results, so everything is perfect, we need only to stop. Okay. And mainly, if we're going to imagine the ideal solution, how it works, we start with problem definition and understanding, right? Then solution design, and then we implement and code that. I keep generating test cases. If something is going wrong, I come back to the implementation and do that. So this is what we just imagine if we go through these steps. However, life is not as easy as this. And the reality is a little bit complicated. So what actually happens, it's completely different from our expectations. So in the reality, whenever you start building any project, having this kind of probably sequence or ideal situation, it's almost absent in practice. So in general, you have to go back and forth with your customer. You need to discuss again. You need to come always, even you reach up to the last stage of solution testing, you can come back to the problem definition. Maybe you're misunderstanding something. So mainly it's like this. Probably you miss something, some details, something you are not designing well. So you keep modifying some going from one step to another and adjusting your code accordingly. You keep testing your system again. Then your user maybe he might only find some bugs. If you have the implementation now, some part of your system could be not as expected. So these all are scenarios that are actual and that are really happening. So in general, it's the whole process that it's not it's kind of interactive way with the customers, which reflects the reality, which is hard, and it's very, very difficult to see some kind of ideal solutions or situations like that one. Okay, you need to keep interacting, changing things, and doing things like that. Okay, now this is what actually happens. And if now we focus on code is done, what else matters? What is beyond code? What is, let's say, more important, or there is a set, or there is several questions that have to be answered actually beyond just developing the software. And some of these questions are more related to how long did it take to complete the work. I would say the slot of time or the exact time, because it's very important, as I was mentioning. I need to know from the very beginning what is expected, how long it will take, what resources are actually required, and also I need to answer the next question: how much efforts is expended to do that work? How many people, or the team or people, or the total hourly working hours, excuse me, and so on. So all these details I need to understand in the start, and this will help me estimate the cost of the project from the very beginning, and probably schedule and manage my project in the right way. And then I probably need to answer the question on how good is the solution once the project is complete. Does the solution solve the complete problem? So this question is mainly about completeness, and all of these questions are much more beyond just coding. So it's based on quality of the code, the design, documentation, the testing, and many other factors can help us understand. It's not like my code is done. No, it's not like that at all. And this is why I would say this is not a coding class. We are going to go beyond coding, okay? This is what we will do. And for like software engineering means now problem is clear. Things are getting more clear for us. It's not like there is a problem specification. I'm going to jump by coding and straight I find my final program. No, I need to go through the specification, the user needs, structure. I need to meet that specification. I need to work correctly. As if changes are needed, I need to change that. I need to have different versions or releases from my final product or software. And if I have many tasks, like I need to divide these tasks based on my team. And you will see in your project there must be, and it's a very important role, what we call the team leader. So it's someone who is going to lead the team. It's not, there is a huge difference between a boss and a leader, okay? And you might know that a leader is someone who's going to really help, to have his hands on, but he's going to have a mission to succeed this project. He's going to divide tasks, he's going to get involved as well. And so we divide a whole project into modules. I would say from bigger image we can have kind of puzzles, and like with that pieces we can come up to the final product or final program. It's not like jumping straight into coding. I would say that again and again. Okay. Now, what are we going to discuss? We are defining the software engineering concept in this first video. And there are several definitions of software engineering in general, but they are kind of talking about a lot of activities that represent the state of the art of developing high quality software. So it must be developed on time. It must be developed within budget. And here you can see from this definition the importance of your software activities. It's not just about just programming. It's not mainly jumping into code. However, it is about maintaining high quality. Maintaining means what? Means even after the first release, we keep checking, we keep like hearing back from users and keep updating and enhancing the quality of the software. Okay, so it's about meeting deadlines, it's about meeting budgets. So all this kind of stuff are really important in order to deal with the potential issues that you may face, and you will absolutely face a lot of issues. So you need to be prepared for that. So in general, you need to try to reduce the budget, you need to try to deal with limited resources and so on. All this is included in software engineering. Okay. Now we can have other like definition, and it's, I would say, the software engineering is multi-person construction of multi-version software. This is another definition, and it is more related to the use of multi-person construction of multi-version software. So as you know, nowadays, I mean, most of the projects are done or conducted in teamwork. So rarely that you find solo engineer working slowly or alone, and it won't let him achieve. Mainly in software engineering, we need to work together. There is like a teamwork in the team and the team leader. So we talk about projects that have probably more than 1 million line of codes. So it's difficult to do that alone. So this is the importance of building groups, building connections, not taking this course isolated in your room, or you need to send some messages in Discord. You need to get to know other students. You need to try to build your team and start from this experience. Okay, I'm talking about the project for sure for now. And now to make this project successful, in general, we need to have multi-versions. Like you have to have multiple releases. And I'm sure that GitHub is a great example in this context. And by the way, I encourage the use of GitHub, Discord. I encourage communication using Slack and all these platforms for your project, because that's really important to show that like this multi-versions part where you have multiple domains, and at some point you may decide to leverage just one version, and then probably you can add more requirements and so on later, okay, with the time. So now moving to another like definition of software engineering, which is it's about the process of solving customers' problem and by the systematic development and evolving large high quality software systems within cost, time, and other constraints. So here mainly all these parts is really important in terms of making sure that we are actually targeting high quality software. It's not only that, but we are trying at the same time to minimize the cost, and we are trying to avoid any delays, or with also we are trying to like manage different constraints. So next, so we are discussing already about the cost, time, and other constraints related to resources mainly here. So we are talking about programmers who are available to develop software, for example, and mainly probably the other costs like having specific platform to be adopted. Probably we need to have I would say some private libraries. Probably we need to use some services, for example, maybe some specific packages that are available. Maybe you can be interested in learning about software containers, maybe about Docker containers, as you know, they are used nowadays in this context of resources, and there are so many other services that are packages, like I was mentioning Docker containers, and but for these services they are not for free, so you need to pay for them, and so this could be included in the final cost of the project. Sometimes you may take this kind of decisions, okay, I'll pay or I won't pay. When you are building your software, you need to be really wise about choosing the accurate resources and so on. So are these kind of advantages basically of trying to decide whether to implement things from scratch, because if, for example, you don't want to opt on reusing existing tools, maybe you want to implement your own. I'm talking in the context of a big company. Many companies, they're having their own solutions. They're not buying some like ready or existing software. So this could be having its own advantages. It's maybe drawbacks, because you know, coding things from scratch is costs, probably it's different. It's different from reusing existing things, but at the end it could minimize the cost. I don't know. It could minimize the cost if it is like done correctly, I would say. So I can give you one concrete example. Like, for example, many companies who have decided to develop a complex website, they are using nowadays Drupal. You might hear about this. Or Drupal, yes, sorry about the pronunciation, Drupal. So it's, as you know, it's an open source. You can Google this, and it's just an open source and free platform, but it could be a little bit complex and to manage and in practice. So we can opt for some solutions which are not the perfect one. We can maybe develop our own. So this is the main idea. And there is always a trade-off between managing what you need to manage and the costs or the time and the constraints. So this is what you need to manage, this conflict, I would say. And sometimes you have inaccurate estimation of the cost also, or sometimes you might have an accurate estimation of the time, and it's happening until today. We cannot deny that it's only limited in that 1970s, and once we are having software engineering concept is solved, it's still happening, but this is much more better than before. Okay. Now, in software engineering, I was just saying that in your project, you're going to imagine kind of having a project. This project involves what we say different stakeholders. We talk about the user, which is the very first or most important stakeholder. And these are the people for whom we are creating this, making this project. They are the end users of this project. They are the ones who are going to use the product. And then there is the customers. And these customers are the ones who are going to pay for the software. They are going to buy the software from you. And you are a software developer and maybe manager. So there is users, customers, software developers, and there is development managers. And mainly these are the four stakeholders involved in software engineering task. I wish that now picture is clear and we are able to understand what is software engineering. Thank you for your attention.